Hi, everybody. A very good day to all of you. Now, today's lesson will be focusing on the O level planning, and you guys already did the practical just a couple of days before the school closure. And I hope that you have done or at least attempted to try the planning question yourself first before we actually go through how we can do this. So, we're going to be focusing on some revision here as well as the suggested answer for the 2018 O-level planning question. Okay, so without further ado, let's begin. We are now moving on to the first big segment of the planning part, and that is the actual independent variable, where the area of independent variable can actually be further broken down into these statements here on the top right hand corner. So we're firstly talking about the action step to obtain the independent variable. And of course, you need to measure and record this particular independent variable itself. Now, you notice also that sometimes, or in fact, you should always talk about a setup of the experiment. And what I mean by saving time, I'm going to show you in the presented answer. So if you take a look at the presented steps here, the first thing we're talking about is to prepare a plasticine ball of mass 50 gram. Okay, and this mass 50 gram, now I'm not saying you have to use 50 gram, but you should give me this dummy value so that the person doing the experiment knows what value they should be starting with. You will notice all your practicals usually give you some value to start off with first, and eventually you have to decide what are the values that you want to include in your data tabulation. Okay, so always give this dummy value in order to score the full credit for your planning experiment. Yeah. Okay, and we're talking about setup or experiment, right? So you can see we write a statement: set up the experiment as shown in figure 1.1a and 1.1b. So the reason for this is that I'm sure you don't want to write things like first you must put up a retort stand, and then after you must use the balls to clamp the pendulum or the wooden boards. Or no, you don't want to do all these things. Okay, so you can just write set up the experiment as shown and so forth. Okay, so step 2 will be to actually measure and record the mass of the bob. Okay, sorry, there's an extra the. Okay, measure and record the mass of the bob as m. So, and then you may want to talk about what are you actually using. You're using an electronic balance in this case. Okay, Now, because you are actually taking the mass of the bob to be the independent variable, so definitely you're going to be changing the bob as you proceed with the experiment. And hence we have step 3. So you're going to attach this ball to the length of string from the setup that you did in step 1. Now the next big section is the dependent variable. Same thing as with the independent variable, you need to tell me the action and then measure and record these dependent variables. Okay, so this one is very straightforward. So step 4. Now you notice that I'm going to write perform step C1 and C2 in order to obtain the time taken for the amplitude to decrease as shown in figure 1.2. Okay, here's the thing. Cambridge is not going to give you credit by just rewriting everything. Okay, because yes, in order to perform this experiment, you need to do steps C1 and C2, correct? But I don't want you to be writing out the exact same words that you see in step C1 and C2 because yes, you will get the marks, but you are actually taking a lot of extra time just to write everything out. Okay, so it is not necessary for you to write out everything. Just perform the steps accordingly to what you need to obtain your data. Okay, so but you still, however, in step 5, you still need to mention the measure and record step. So you're going to say that you measure and record the time taken for the amplitude to decrease, and this is the first time you get the dependent variable. This will be T1, and what is the instrument you're using. Okay, so the next segment is about precautions and process data. And for precautions, if you remember doing pendulum experiments, usually we must take some average of some sort, and hence I want to repeat steps 4 and 5 to obtain a second reading, which is T2. Okay, and step 7, which is your process variable. Okay, now you realize that this t is where it's coming in now, which is actually what? T1 plus T2 divided by 2, isn't it? Okay, and this is now in relation to the experiment where we said that we said that T is directly proportional to M. Okay, so this is how now we make some relevance to the context given in the question. Okay, now we're looking at the key steps in order to form the table. Whatever physical quantities you have included in your planning, remember this time we have M, we have T1 and T2, and we have T. So all of this data is to be included into a table. And you need to also state the description of steps that you're going to take in order to get different dependent variable values. Okay, so in this case, since we're using balls of plasticine, right, we're going to prepare additional balls of plasticine and replace the pendulum bob. So replace the pendulum bob, and you need to repeat the steps of this planning that you have done for an additional 5 values of M. Okay, so this number 5 is very important because for with any experiment, right, you need a minimum of 5 values. So of course you can tell me, but sure, here got now 5 plus 1, right? I think it's perfectly fine. You can have 6 if you want to be playing it safe, but the minimum values or the minimum number of attempts that you should be doing on the values should be 5, no less than 5, in order for you to eventually sketch a proper graph. Yeah. Right, we have come to the last section of how to answer planning questions in the practical, and that is really just about data manipulation. Okay, so here are the statements that we want to take a look at. And the first thing that you want to do, and usually in most of the planning questions, is that you are asked to actually write the correct statement in order for you to plot the graph. Okay, so in this case, we're just plotting a graph of T against M, right? T against M. And the next step is usually some manipulation of data based on the equation given to you at the very start. Now you realize, of course, in this question, there is no such equation, but In some other questions, you may be asked to either talk about the gradient, or you may be asked to find the y-intercept based on the equation given to you. Okay, so if in the event you're asked to do something like that, now let's say assuming that we have y equal mx plus c, and you're asked to make m the gradient the subject, you need to show in your steps, right, the final equation that you're going to get by making m the subject. So in this case, this will be m equal y minus c over x. And you need to show this as a final equation if, let's say, you are asked to find the gradient, and maybe the gradient is related to something that you are actually doing in the practical itself. Okay, now of course for this question there isn't such a requirement. However, this question is a little bit different in the sense that they now ask you to sketch how the graph would look like. Okay, so just to share with you, in 2018, the students, quite a number of them actually missed this last part out, and they did not sketch the graph, and which is a pity because there's an easy 1 mark. The question already stated that the suggested relationship is that t is directly proportional to m, and so all you needed to do is to sketch a straight line graph that passes through the origin. Okay, so it's really very simple. It's very easy for you to score the mark. Please ensure that you have sketched the graph in your answer as well. Okay, so if I break it down once more again, remember, it's about the independent variable, the dependent variable. It's about the precautions and the process data that you need to calculate, the table data, and the data manipulation. Okay, so if you can remember all of these 5 sections of planning, right, it becomes very much easier for you to actually write out the entire planning sequence. Okay, so all I need you to do from here now is to check through your own planning. Can you just include the necessary steps that you may have missed out? And I want you to submit your corrections and planning on Google Classroom by today. Okay, so today is very nice and short and sweet, but you need to take some time, maybe go through the entire slideshow again and ensure you really know how you're going to do future planning in the practical itself. Okay, so I will be covering the last part of, not sorry, the last part, the next part of electromagnetism in tomorrow's lesson. I'll see you then. Right, bye-bye.